Hi everyone. I'm going to go over some review and some new concepts when finding the domain and range of continuous functions or continuous graphs in general. So this problem is a review from what we learned last week. So if we're looking at the domain, remember we're looking at the x values, so we're going to look at the x-axis and we're going to put walls around the graph to see where it starts and stops. So I can see that this is one wall of the function. This is where it starts. And then I can see that the other wall is right here where the last point of this graph is, and this is where it ends. So I know the y-axis right here, this is 0, and this is 5. So I know the domain can be any of these x values all the way from 0 to 5. And because there are two endpoints, at the end of each one, they're closed. So just some key features that we recognize. It has two closed endpoints on both sides. That's going to be critical when looking at each of these graphs. So I know that x can equal 0, x can equal 5, and it can equal any number in between. So we're going to say x is greater than or equal to 0 or less than or equal to 5. So that's our domain. And then if we look at the range, remember we're looking at our y-axis for range, and we put the floor for where the bottom of the graph is. And so the very first point starts here. So this is the floor, and that's at 2. And then we see that the ceiling, so we're going to do floor and ceilings. And I can see that the ceiling of the function, the top of the function is right here, and that has a y value of 7. So I know that the y value can be anything from 2 all the way up to 7. So y is greater than or equal to 2 or less than or equal to 7. Okay, so now for this graph, we see a couple different things. We see that on one end, there is an open endpoint, and then on the other end, there's a closed endpoint. So some key features we want to recognize: there's one open endpoint and one closed. What that means is there is a point at 3, -3 here. So that means that x can be 3 and y can equal -3. But because this endpoint over here is an open circle, it means there is no point there. So x is not going to equal -4 for the x or 1 for the y. So we write the domain. We still want to put our walls up around the graph. So I can see that the graph starts here at -4, but remember there's no endpoint there. So I'm going to mark already that x has to be greater than -4, and I'm not going to put that line underneath that less than sign because there is no point there. It cannot equal -4. And then the right wall of the function, I notice, is right here where the last endpoint is, and that has an x value of 3. And there is a point there, so I know x can be equal to 3 or less than 3. So when I see an open circle, I'm going to put a less than sign, and when I see a closed circle, I'm going to put a less than or equal to sign. So then to do the range, remember putting our floor and our ceiling. If we look at the bottom of the function, we see how the bottom point, the very lowest point, is right here at -3, and there is a point there. So I know that y is going to be greater than or it can equal -3. And then I know the top of the function is right here at 4. And in fact, when you see a line, there are points all on the line, so there is actually a point there, even though it doesn't explicitly show you. Remember, anywhere you see a line, there are points on it. So I know that y can also equal 4. Now I know this is kind of confusing that there's a open circle right here, but that only helps us with the domain. It doesn't matter with the range because the function ends up actually going higher than that point to up to 4 for the range. Okay, so for this example, we see how there are two open endpoints, or two open circles on the end of each both sides of the graph. So here for the domain, again, let's put the walls where it starts. We see that it starts over here at -4. And we see that the right side ends at 5. So it's between -4 and 5, but there are no points. They're open. So when the ends are open, we use a less than sign. X has to be greater than the -4 or less than 5. It cannot equal both. If it could, there would be a closed point, and we don't see one, so it's open. And then for the range, looking at the floor and the ceiling where the bottom of the function is, we see the bottom of the function starts right here at -3. And this is an open circle at -3. So we know that y has to be greater than that -3. It cannot equal -3. And then the top of the function, so this is our floor, this is where the bottom is. Our top, we see this very point at the top here. That's the very top of the function, or well, the graph, and that's at a y value of 3. So there is a point there because the line is there and it touches that, and there's no open circle there. So the y can actually equal 3. All right, in this example, we see something new for us in terms of these graphs. We see one endpoint and it's closed. So let's write one closed endpoint, and we see an arrow. And so if we think about what the arrow means on our number line, anytime you see an arrow means it keeps going. So it's really not an endpoint. The function or the graph will keep going. So let's just remember what our domain means. Domain has to do with the x values, the x-axis. And so we see where the function starts, and that's at this point right here. And this point is at 1. And since there is a closed point there, we know we're going to say that x is greater than or it could equal 1. And then on the right side, we see how we normally would put a wall right here, but because this arrow is there, it means that there's no endpoint. There is no wall on the right side. So we actually get to leave our domain as just x being greater than or equal to 1. And then for the range, looking at the y-axis, we see the bottom of the function is right here, and that's when y is 0. So we know that y has to be greater than 0, and it could also equal 0 because we see this point right here. I covered it up, but there's a point here, which means that y can actually equal that. And then if we try to put a ceiling on here, normally we would see, oh, that this is a ceiling, but this arrow means that it's going to keep going. It's going to keep going up, up, up. So we cannot put a ceiling on it. The function will continue to go up the y-axis. So again, the range for this function is just y is greater than or equal to 0. So similar to the last one, we see that there is, ooh, that is interesting. All right, let's go back to our pen. We see that there is one closed endpoint and an arrow, just like the last time, but the arrow's on the other side. But we're going to continue to put the walls and the floor and the ceiling up as we can. So we still think the domain and know that the domain is the x-axis and range is the y. So let's try to put our left wall up. So we see right here at this point is where the function looks like it's kind of starting on the left side. However, remember that this arrow means that it's going to keep going. So this function doesn't just stop right here. It's going to keep going this way. So what that means is we can't really put a wall up because every time we try to put a wall up, it's going to keep getting pushed back. So I'm going to erase this wall. We cannot put a wall on this side because of this arrow. So we know that, let's go look at the right side. So we know on the right side, the wall right here at 5 is going to be where the function ends because there is an endpoint right here. So we know that it's not going to be over here to the right. So we know that x has to be less than, but it could also equal that 5 because there's a closed point there. So it can be anything less than 5. So I'll show you with the highlighter. It can be anything over here, because this arrow is going to keep going and keep going. So it's going to be any x value less than 5. It's not going to be over here in the greater than, because there's an endpoint right there. So let's go ahead and erase all these lines. So now if we look at the range, remember the range is looking at where the bottom of the function or the graph is. And so here, if we were to look and try to put a floor here, we see again that this arrow is really going to push it down. And if we try to put a floor, the arrow is going to keep pushing it down. So there is actually no floor. But if we look at the ceiling, we see that the top of the function is at this point with that endpoint, and then that's at 2. And that's not going to be higher than that. So we see that the function is going to be all under here. And if we look at the y-axis, the y's have to be less than this 2. So y is going to be less than. It can also equal to, because there's this point right here. So y is less than or equal to 2. It could be any value, any y value down here. So look at the y-axis and see that it's at this point or below. Okay, and then one last graph, we see that there are 2 arrows. So in the last 2 slides, we saw 1 arrow. When there was 1 arrow and 1 endpoint, there was 1 interval. Meaning it had to be like x is less than this, or y is greater than or equal to this. So there was only one side of the interval. When we have 2 arrows, the domain and range are going to be, well, let's take a look at it. So for the domain, looking at a floor and a ceiling, the domain, let's talk about the walls, right? Left and right, the x-axis. So we try to put a wall here and a wall here. It looks like this is at -7, but remember the arrow means it keeps going. So there is going to be no wall on the left side. There's no limit. And then on the right side, there's actually no limit over here, because this arrow continues to push this to the right and push this to the left. So actually the domain is any real number, meaning it could be any x value, because it's going to the left and to the right with unlimited, there's no walls. And then if we look at the range, looking and see if we can put a floor, the bottom of the function looks like it's right here at -10. But again, this arrow will continue to push the floor down, having no limit. So there's no floor. And then if we look at the top of the function, looks like it's right here at 5 maybe. But again, the arrow will push it forward and push it up. So this is going to continue to go up and continue to go down. So for the y-axis, it's going to continue to increase. And so it'll continue to go up the y-axis. And this is going to continue to decrease. So this is going to continue to go down the y-axis. So also the range is any real number. So remember, if you see 2 arrows, it's going to be any real value for domain and range. And then on the last 2 slides, if you see 1 arrow and 1 endpoint, you'll have just 1 interval for the domain and for the range.